Welcome you all to the new session on block diagram reduction technique. In last few classes, we discussed about basics of block diagram representation of a control system, how to use block diagram reduction technique in order to get overall transfer function of a particular system represented by block diagrams. And we discussed about the associated rules of block diagram reduction techniques. And we discussed around 7 rules on the same. We solved some numericals on block diagram reduction technique, applying those rules. Today we'll discuss about some more problems on block diagram reduction technique. So to start with, let us discuss the topics to be covered in today's lesson. Here we'll discuss only about solution of problems, solution of some more complicated problems, and to start with, let us consider this example. Here a block diagram is given to us. We'll apply the block diagram reduction rules which are discussed earlier in past classes to get overall transfer function, that is CS by RS, for this block diagram. Now see, obtain closed loop transfer function of the following using block diagram reduction technique. Here CS is output, RS is input. So we are asked to obtain overall transfer function, that is output divided by input. This we need to obtain. Now, to get this overall transfer function using block diagram reduction technique, how shall we proceed? That we will discuss now. See here, the block diagram shows it has some summing points. It has few takeoff points. Now, for better understanding, let us mark all the summing points and takeoff points as shown in next slide. So for better understanding, let us mark all the summing point and takeoff points. See here, summing point A, summing point B, takeoff point C, summing point D, takeoff point E, and takeoff point F. Now, from this block diagram, it can be clearly seen that, as I said, for block diagram reduction, sometimes it is necessary to shift summing points before a block or after a block. Sometimes it is necessary to shift takeoff points before or after a block. So see, let us consider this summing point. If this summing point is shifted before G1, then what will happen? This summing point will not be there. So G1 and G2, these two will be connected in cascade. So to make this series connection between G1 and G2, we can move the summing point before the block. Similarly, if we can shift this takeoff point before G3 or after G4, anything. If this takeoff point is shifted, then this takeoff point will not be there, which will make series connection between G3 and G4. Likewise, so it is up to us what we need to do. Someone can opt for shifting the takeoff point before G3. Someone can opt for shifting the takeoff point after G4. So it's up to you. You can do anything you want, but make sure that you are aiming towards reducing number of blocks so that you can get overall transfer function. And to do that, aim towards making series connection, parallel connection, or feedback connection between the blocks For that, you need to shift takeoff points or summing points as required. So let us move to next slide. See, here it is mentioned, combine G1 and G2 in series. Okay, let us move to previous slide first. See here it is written, shift summing point B before G1. So as I already said, shift this summing point B before G1. Why to shift summing point B before G1? To combine G1 and G2 in series. If this summing point B is shifted before G1, G1 and G2 will be in series. Now, when B is shifted before G1, so initially this was the summing point, now B is shifted before G1. But after that, what did we do? See, if the summing point is here, if the summing point is shifted here, then what will happen? G1 and G2 will be in series. But we cannot make feedback combination of G1, G2 and this H1. Why? Because of the summing point in between. So what we need to do is, first we'll shift this summing point before G1. So now B will be here. Now we'll interchange A and B. If A and B are interchanged, it will look like this. It will look like this. So as A is being interchanged with B, so A will be now here, which will make a feedback combination of G1, G2 and H1. So you need to do this accordingly. So our first task is to shift summing point B before G1 to combine G1 and G2 in series. Then interchange A and B. Why do we interchange A and B? So as to make feedback combination between G1, G2 and H1. To combine cascade connection of G1, G2 in feedback with H1. So hopefully this point is clear, why B is to be shifted before G1 and why A and B need to be interchanged. This was the first task. So what we have done here, B is shifted before G1. So whenever a summing point is shifted before a particular block, if the corresponding signal will be multiplied by 1 by G1 block. That is why it is multiplied by 1 by G1. As B is shifted before G1, so the signal entering at B, this signal entering at B will be multiplied by 1 by G1. We have discussed these rules before, that if a shift summing point is shifted before a block, then it should be multiplied, the signal should be multiplied by 1 by G1. Now, what else we have done here? Similarly, this takeoff point need to be shifted before block or after block. So if we shift it after block, if a takeoff point is shifted after a block G4, then the signal, corresponding signal will be multiplied. This signal, takeoff point, from takeoff point this signal is coming. So as it is shifted here, so now it will be like this. So whenever a signal is shifted after a block, when a takeoff point is shifted after a block, it should be multiplied by 1 by that block transfer function G4. So 1 by G4 multiplied by S3 is H3 by G4. So this H3 by G4 we have got, initially it was H3, it is H3 is divided by G4 because we have shifted takeoff point E after block G4. This 1 by G1 is multiplied here as this signal which was entering at B this B is shifted before the block. So finally, after making this shifting, we'll get this waveform. What are the changes we have made? We have interchanged A and B. A and B interchanged. We have shifted B here, then A and B interchanged. We have shifted takeoff point here. Accordingly, this H3 is H3 by G4 and 1 by G1 is introduced in the system. Now, when we have done this, see now G1, G2 are in series. With this series combination, H1 is connected in feedback. Similarly, as this takeoff point is shifted here, now G3 and G4 are in series. With this series combination, H2 is in feedback. Now, so after making those conversions, the signal was like this. The block diagram was like this. Now we'll combine these two in series. So here it is written, combine G1, G2 in series with the combination, combine H1 in feedback. So combining this whole block diagram, we'll get G1, G2 by 1 plus G1, G2, H1. So this is replacement of this entire block. Similarly, G3, G4 in series with that combination, H2 is in feedback. So G3, G4 in series with that, H2 is in feedback. So this entire block will be replaced by this one, G3, G4 by 1 plus G3, G4, H2, following the basic rules. And what else we did here? We have combined these two in series as well. So H3 by G1, G4. H3 by G1, G4. Okay. Now, now these two are in series. With this series combination, this H3 by G1, G4 is in feedback. So what would be overall transfer function? Combining these two in series, it will be XY as forward path and Z is feedback path. So G by 1 plus GH, 1 minus GH. Here this signal is entering at plus terminal. So the formula will be G by 1 minus GH. G means XY and H is Z. So combining this XY, X into Y means G1, G2, G3, G4 divided by 1 plus G1, G2, H1, 1 plus G3, G4, H2. So by simplifying this, XY by X, 1 minus XYZ based on this, by substituting X, Y and Z values, you'll get this as overall transfer function. That is how we can make this conversion to determine overall transfer function. Now let us move to next problem. In this problem, see, one new thing appears here. There is not only one input. In all the problems which we already discussed in previous class and today's class, till now all those problems are associated with one input. But if you have a multi-input system, like RS is one input and DS is another input. DS is normally termed as disturbance input. So if you have two inputs, then how to get transfer function of the overall system for those two inputs? So for RS input, transfer function is CS by RS. For DS input, transfer function is CS by DS. As like superposition theorem, while finding CS by RS, consider DS as 0. So we'll consider one input at a time. For that time, other input will be considered as 0. So for this problem, how to solve it? The problem block diagram is mentioned here also. Now see here, how to write this equation. This is US. So US equals to RS into GF, RS into GF plus GCS into ES, plus GCS into ES. So this is US. Similarly, CS equals to what? This is CS. CS equals to, see, this is DS signal and this is GI into U, US into GIS. So US into GIS plus DS, which is multiplied by GP. So this signal is DS plus GI into U. This signal is this. This is the signal which is passing through GP block. So CS equals to GP multiplied by D plus GIU. Okay. Now what is ES? ES equals to RS minus CSHS. ES equals to RS minus CSHS. So these are the basic equations. These three are basic equations following this block diagram. Now CS can be written as this. How? CS equals to what? CS equals to GP into DS. So GP into DS plus GP GI US. GP GI US means what? This. So by substituting this US value in here, by substituting US here, you will get GI GP into US will be substituted by GFRS plus GCU ES. Okay, so this is CS. Now CS can again be simplified as GP into DS plus G1 GP GFRS plus GC into ES. ES can be substituted by this one. So ES is substituted by R minus S, HCS. Now after simplification, you'll get this one. Okay, just by making possible conversion, you'll get this one. So we have got CS in terms of the two inputs DS and RS. Now from this equation, if you want to get CS by RS, if you want to get one transfer function CS by RS, as I said, while getting transfer function for RS input, make other input DS as 0. So as we are making DS input as 0, so here in equation 1, while finding CS by RS, make DS as 0. So CS by RS, by making DS 0, this term will become 0. So CS by RS will be G1 GP into GF plus GC, G1 GP, GF plus GC divided by this. Similarly, while to find, this should be DS. While finding CS by DS, we will let RS equals to 0. So if RS is 0, so then this entire term becomes 0. So CS by DS equals to GP by 1 plus G1 GP GCH. So that is how we can find overall transfer function for multi-input system by considering one source at a time, and for that time the other source will be considered as 0. Now for this problem, see here, we have multi-input, multi-output. So first we discussed about single input, single output. Then we discussed about multi-input, single output. In last problem we discussed about multi-input, single output. In this problem we'll discuss about multi-input and multi-output system transfer function. So how to get CS by RS, C1 uh, C1s by R1s, C2s by R2s, C1s by R2s, C2s by R1s. These four transfer functions will be deriving here. Now see here, C1 equals to what? C1 equals to this signal minus this signal into G1. So C1 equals to G1 multiplied by G1 into RS minus this signal is G3C2. This signal is G3C2. So C2 through G3. So this signal is G3C2. This signal is R1S. So C1 equals to R1 minus G3C2 into G1. Similarly, C2 equals to what? C2 equals to plus this minus this into G4. So G4 into R2 minus C1 G2. Okay. So C1 equals to G1 into R1 minus G3. C2 of this can be substituted by this. So G3 into C2 equals to what? G4 into R2 minus G2 C1, that is substituted here. So we'll get equation for C1 here. Similarly, equation for C2 can also be obtained by replacing this C1 from this equation. So these are two equations for C1 and C2. Now from equation 1, this equation 1 can also be written as C1 equals to what? G1 R1 minus G3 G4 into R2 into G1. This G1 will be multiplied divided by 1 minus G1 G2 G3 G4. Now how did we get this equation? How did we get this equation? See here, we have this G2 G4 G3 G4 G2 into C1. This C1 part will be moving here and will be coming as division. So just making simplification of this, we will get this one. Just simplifying this, we will get this one. So C1 and C2 can also be written as this. So what we have done here, here is also C1, here is also C1. So we have taken all the C1 together in left hand side and we have got equation for C1 and C2 in equation 3 and 4. Now in matrix form, we can write these two equations C3 and C4. 3 and 4 equation can be written in matrix form. In left side there will be C1 C2. In right side this is G1 for this term, G1 by 1 minus G1 G2 G3 G4, G1 by 1 minus G1 G2 G3 G4 for this R1, and for R2 it will be G1 G2 G3 G1 G3 G4 divided by 1 minus G1 G2 G3 G4 for R2. Likewise for C2, this is minus G1 G2 G3 G1 G2 G4 divided by this minus of this and this. So this is matrix representation of equation 3 and 4. Now, to find C1 by R1, as I said, we need to find 4 transfer functions: C1 by R1, C1 by R2, C2 by R1, C2 by R2. While finding transfer function for R1, while finding transfer functions for R1, let us make R2 input as 0. That is why we have written considering one input, either R1 or R2 present at a time. While considering one input at a time, other input should be considered as 0. So by making this term, this R2 0 for the first time, what will be C1 by R1? C1 by R1 will be this term, G1 by 1 minus G1, G2, G3, G4. Similarly, C2 by R1 will be this term. Now, while finding C1 by R2, that means while considering R2, this R1 term will be considered as 0. So C1 will be, C1 by R2 will be this, and C2 by R2 will be this. So that is how you can get overall transfer function for multi-input, multi-output system as well. So what we discussed today? Today we discussed about how to get overall transfer function of a complex system having one input and one output. In first problem we discussed single input, single output systems transfer function determination. In second problem we discussed about multi-input, single output systems transfer function determination. In third problem we discussed about multi-input, multi-output systems transfer function determination. So for today this is it. In next class we'll be discussing another transfer function determination method, that is signal flow graph based approach, because block diagram reduction technique is a bit difficult for very complex systems. In order to reduce the complexity associated with transfer function determination for very complex system, what we need to do, we need to follow approach of signal flow graph, and we need to use Mason's gain formula. What are Mason's gain formula? What is signal flow graph? That will be discussed in the following few classes. Thank you all.